Hi, hello, vanakkam and welcome back to yet another episode on your DevOps Studio YouTube channel. So today in this video, I'm going to answer one of the questions that's been asked to me today, that what tools and techniques do I need to learn to become an Azure DevOps engineer. So in this video, I'll take you through each and every tool that you have to learn for each and every phase of the DevOps engineering. Say for example, like we have 8 different stages, starting from planning to coding to building and then testing, and then we do have containerization, and then we do have monitoring, operations, deploy, release, and again cloud platform on the top. So I'll take you through each and every stage, and then I'll explain you like what is that tool is all about and how does it help you in terms of becoming an Azure DevOps engineer, full fledged. And again, in our channel, we are going to discuss more about that. Like we're going to jump into more tools, more videos on each and every tools and techniques. So please do subscribe to our channel and watch our channel for more information. And don't forget to share our channel and subscribe. Like today, if you have any other questions or comments, please do comment in the comments section. And I'll get back to you very soon as possible. Thank you, and moving to the next topic. So we'll go through one by one, stage by stage, and I'll explain you what tools do you use to become a full-fledged DevOps engineer. So we'll start with the planning stage, the stage one, the planning, where we use two tools mainly, the Jira, Confluence. So these are the two essential tools in DevOps that are widely used to streamline the project management, for team collaboration, and for knowledge sharing. So I'll break down all those pointers for you, starting from, I'll just first start with Jira. So what is Jira? So Jira is a project management and issue tracking tool developed by Atlassian, and it is used for tracking bugs, for planning sprints, for managing tasks, and maintaining agile workflows. So why we use Jira in DevOps? So for streamlining issue tracking, say for example, to organize the tasks and to organize the bugs and for the organizing for the features. So we organize tasks, bugs, and features effectively. So for that we use we use Jira. And agile support. So Jira offers robust support for Scrum and Kanban boards. So for say for example, like we can organize all these Scrum meetings and Kanban boards using the Jira. Like we can track the status and we can enable better sprint planning using Jira. And when it comes to the integration, so Jira integrates seamlessly with CI/CD tools, with version control systems, say for example like Git or any other monitoring tools. And when it comes to real-time collaboration, Jira allows teams to collaborate on task statuses and priorities and deadlines. So on all these aspects, Jira is a better tool in terms of DevOps. And as an Azure DevOps engineer or any DevOps engineer, Jira is a must tool to learn and how to use. So we can set up projects, we can create a project, we can configure it for Scrum, Kanban, or a custom workflow, and we can create and manage issues. Say for example, we can define an issue as stories or task or bug or epic. And also we can assign the team members, we can set priorities, and we can add due dates as well. So the due date, when I say it's going to be the end date, and we can plan sprints. So we can add tasks to sprints using a backlog. So we do have a backlog where we can add the tasks to the sprints, and we can monitor the progress on Scrum board or the Kanban boards. And also when it comes to the tasks, we can actually track the progress of them. So by using the visual boards or by using burn down charts and reports to assess the projects like progress. Again, I told you in one of my previous videos that we're going to discuss about the various charts. What are they, and what do they really tell about the status of the progress and everything. So we'll see them in our upcoming videos. And then when it comes to integration with tools, yes, we can connect Jira to CI/CD pipelines, monitoring tools, and Confluence for seamless operations. And when it comes to the benefits of Jira and DevOps, so Jira improves the task organization and visibility, and it promotes accountability with clear assignment and deadlines, and it facilitates agile practices and continuous improvement. It also enhances cross-functional collaboration. And then moving on to Confluence. So what is Confluence? So Confluence is again another team collaboration and documentation tool, which is also developed by Atlassian, and it acts as a centralized knowledge repository for project documentation, for meeting notes, and design specifications. So why do we use Confluence in DevOps? So Confluence actually acts as a centralized knowledge base where it stores documentations, runbooks, and operational details in one place, and it also improves collaboration. So teams can edit, they can comment on and share documents in real time. It can be linked with Jira very easily. To for any if you want to check for relevant documentations, it can be easily navigated without any issues. And when it comes to version control, it maintains version history to track changes and updates. So how to use Confluence? So you can create spaces. You can organize documentations into spaces for projects, teams, or topics. And we can add pages as well. We can use templates to create structured documentation, for example, like meeting notes, incident reports, and also we can embed any image, can add any code snippets, and then also can add links to the Jira issues. And when it comes to collaboration, we can use comments and mentions to engage with team members, and also we can collaboratively edit documents with real-time updates. And when it comes to searching and organizing, yes, you can utilize Confluence's powerful search to find documentation very quickly, and also we can categorize content with labels and hierarchies. So what are the benefits of Confluence in DevOps? It actually, the Confluence enhances the transparency and knowledge sharing. So you say, in case if you want to find any documentation in terms of a particular item, it's very easy for you to find that detail in the Confluence. You can just type in the search box and you can easily find it. And also it reduces siloed information by consolidating data into a single source of truth. And it improves onboarding for new team members with accessible documentation. It simplifies incident management by linking runbooks and troubleshooting guides to Jira tickets. So how Jira and Confluence help you become a DevOps engineer? So that's another question, right? So both tools, both Jira and Confluence, improves cross-functional team collaboration, which is again a key DevOps principle. And when it comes to workflow efficiency, so it actually streamlines task management and documentations actually save time and reduce errors. And the familiarity with Jira's agile workflow prepares you for a real world DevOps environment. And Confluence actually ensures you are adept at managing and accessing critical documentation. And when it comes to hands-on experience, you can use these tools, which provides practical exposure to DevOps pipelines, issue tracking, and knowledge sharing. So now we'll move on to the next stage, and the next stage is going to be the coding. So now moving on to stage 2, the coding. We have two tools. One is GitHub and VS Code. And what is GitHub? So the very first one which I wanted to discuss with you. So GitHub is actually a web-based platform for version control and for collaboration, for building on Git. So it actually can do all these on GitHub, and it actually allows teams to manage the code repositories, can collaborate on projects, and it also can track the changes. So why do we use GitHub in DevOps? Oh, sorry, I think it has not been updated properly. Let me just get back. Yes, now it is fixed. So GitHub and VS Code. So why do we use GitHub in DevOps? So we can track changes to code. We can make collaboration seamless. So that's what we are seeing more about Git and GitHub. So actually, this is a web-based platform for version controlling and for collaboration, which is built on Git. And actually, there are other tools, like we do have GitLab and other tools. But actually, as an Azure DevOps engineer, I personally would advise you to learn GitHub. We are going to have more sessions on Git and GitHub in the upcoming days. And it actually, GitHub allows the teams to manage the code repositories, collaborate on projects, and track the changes. And in fact, it actually helps as a DevOps engineer, it actually more useful for you to track the changes to code, make the collaborations seamlessly, and actually it facilitates the pull request. You can do code reviews, you can track the issues, and you can very well integrate that easily with tools like Jenkins, GitLab, GitHub Actions, and project management tools like Jira. So again, like we have discussed about Jira in the previous stage. So actually it integrates very well with Jira. And for doing any scheduling actions, for doing any deployments, you can very well use the GitHub. And for GitHub Actions, actually enable the automation for testing, for building, and for deploying applications as well. So how do we use GitHub? So we can actually create repositories. We can set up public or private or enterprise repositories to host our code, and we can use Git commands to add, commit, and push the changes to our repository. And we can do branching and merging, where we can create branches for feature development or for bug fixes, and we can use the pull request to merge the changes into the main branch after review. We can actually collaborate, we can assign the issues, label the tasks, and conduct peer code reviews, and we can track the progresses with the GitHub projects. Can even automate or we can create workflows for CI/CD, such as running tests or for deploying applications. So when it comes to the benefits, GitHub simplifies the collaboration and code management, and it actually provides a robust version history and rollback options. It streamlines the CI/CD pipelines with GitHub Actions, and also it enhances the team's productivity with built-in project management tools. And moving on to the next one in this staging, in this coding stage, it's VS Code, the Visual Studio Code. Actually, this is again a lightweight open source code editor which is developed by Microsoft. So it actually from the same organization. Actually, it supports numerous programming languages and extensions for DevOps tasks. Like we can bring in more DevOps related extensions, and they are like very useful for you. And it actually combines code editing, you can do debugging and Git integration all in one tool. VS Code is actually very efficient. Although it's very lightweight, but still it's very efficient. And it actually offers extensions for Docker, for Kubernetes, for GitHub and CI/CD. So all the DevOps related tools can be integrated, almost all the tools. And it works on Windows, Mac OS and Linux, and it enables real-time collaboration through extensions like LiveShare. So how can we use VS Code? So we can install extensions. You can add extensions for GitHub, for Docker, for Kubernetes and more. That's what I told you. And we can link the Visual Studio Code to our GitHub repository, and we can use the source control panel to manage the commits, to manage the branches and merges, and it also works with the code. We can write, we can debug, and we can test the code with built-in and custom tools, and we can use Docker and Kubernetes, and can leverage extensions to manage containers and clusters directly within VS Code, Visual Studio Code. And also you can collaborate with LiveShare. You can share our workspace with team members for real-time coding and for debugging. So some of the benefits of VS Code is we can centralize the code, and we can use it for debugging and for integration with DevOps tools. And it also improves the productivity with keyboard shortcuts and IntelliSense. VS Code actually simplifies the container and cluster management with Docker and Kubernetes extension, and also it facilitates real-time team collaboration as well. So now we'll move on to the next stage. So we do have the next stage is build, and we'll see what we have to learn when it comes to the build stage. So moving on to the third stage, the build. So in this stage, if your project, or if you want to if you are working in a team where they use Azure DevOps, the ADO, so in that case you have to use the Azure DevOps pipelines. So Azure DevOps pipelines is the core of CI/CD services in Azure DevOps, which allow you to automate the build and release processes. So it mainly focuses on YAML pipelines, where you have to learn to define the pipeline as a code, and you have to understand the GUI for building pipelines, and you have to configure the self-hosted and Microsoft hosted agents for building the agents, and also you can set up continuous integration and scheduled builds. So all these is possible through the Azure DevOps pipeline, and you can do the build using the Azure DevOps pipeline. And then coming on to the other tools, so these tools actually integrate into Azure DevOps pipelines to handle the compilation and packaging of code. Say for example, if you are using Java, so in that case you have to use Maven. So you have to automate the dependency management and builds, and you have to learn how to configure POM, the pom.xml, and integrate it with Azure pipelines. And if you are using Java or any other languages, you can use Gradle, which is a flexible build automation with scripting support, and it also use build.gradle to define the build tasks. And then if you're someone who is using .NET projects, then MS Build is the right tool to learn, where you can learn the Microsoft build engine, which is used for building and packaging .NET applications. And also you have to learn how to configure the .cs project or .sln files. So all these things you can learn, you have to learn for your building stage. So these are the tools which are used in the building stage, and you have to very well understand how does this work and what technology you're going to choose, whether it's going to be Java or whether it's going to be .NET. So mostly if you're using Azure DevOps, it can come under the .NET, and then you can choose MS Build, or else you can even choose Azure DevOps pipelines as well. So we'll now move on to the next stage, that is the testing. So now moving on to the stage 4, that is testing. So in the testing stage of the DevOps lifecycle, we have to ensure the code quality, like whatever we have sent. So all those things has to be ensure that they are in a good quality, and security and functionality has to be tested through automated testing, and we have to analyze them. So that's very critical. So I'll let you know what are the tools that as a DevOps engineer you must learn. So in this stage, say for example, oh come on, let me just quickly revamp it. So yeah, coming back to the stage. So the first tool which I would advise you to learn is SonarQube. So SonarQube is actually a popular tool for static code analysis, and it also helps you to detect code quality issues, for detecting bugs, and for detecting any security vulnerabilities. And actually it integrates seamlessly with Azure DevOps pipeline. So that's the reason I recommend you learning SonarQube. And it actually focuses on the code quality, like for example to understand metrics like maintainability, for understanding the reliability, and for security. And also it helps you to customize the quality profiles to enforce coding standards. It also set up, when it comes to integration, you can set up SonarQube in Azure pipelines for automated code analysis, and you can learn to interpret the SonarQube dashboards and reports. So all these things has to be focused on when you're learning SonarQube. So how can we use SonarQube? So you can install SonarQube and you can set up a server. It can be either a self-hosted or it can be a cloud-based, and you have to add the SonarQube Azure DevOps extension to your pipeline, and you can configure a SonarQube task in your pipeline YAML file, which will add tasks for analyzing code and for publishing results. And you can view analysis results in the SonarQube dashboard. So we'll see all these, whatever I've discussed will be demoed you in the upcoming videos. And when it comes to the other set of tools, if I say for example I'll talk about the JUnit, NUnit, and XUnit. So these are testing used for testing individual components of Java, for .NET, and any other applications. So you can integrate these frameworks with Azure DevOps pipelines, and you can use them for any automation of API testing and integrating it with CI pipelines. And there is another tool, another one, which is the Selenium, which is very useful when you are interested to learn continuous testing. Say for example, you can automate the testing process to ensure any for faster feedback and for early detection of issues. So that's another important tool, I would say, if you want to learn as an Azure, to become an Azure DevOps engineer. So SonarQube, Selenium, JUnit, NUnit, and XUnit are the testing related tools that you have to learn as part of your DevOps engineering path. And then next, all the other things will be like you will discuss about the containerization, and we'll move on to the next part, which is containers. So now moving on to the next part, in terms of the containerizations, the only thing that you have to learn, you have to know, you have to understand the end-to-end possibility of this tool is the AKS, which we call it as Azure Containers, Azure Kubernetes Service. Azure Kubernetes Service, yes. So this is actually a managed Kubernetes service. Basically Kubernetes is open source, but still Azure Kubernetes Service is managed by Azure. Azure AKS is managed by Azure, and it is actually provided by Microsoft Azure, which simplifies the deployment, the management, and operations of Kubernetes clusters. And actually, why do we use AKS in DevOps? So actually AKS handles provisioning, scaling, and upgrading Kubernetes clusters, and also it reduces the operational overhead associated with self-managed Kubernetes. And when it comes to integration with Azure ecosystem, so it actually seamlessly integrate with Azure services like Azure Monitoring, Azure DevOps, and Azure Security Center. And also it supports Azure Active Directory, which we call it as Azure AD, or now it is called as changed to Microsoft Entra for access control. And it automatically manages containerized applications across multiple nodes, and it also ensures high availability and scalability. So when it comes to cost optimization, you can only pay for the virtual machines that you use, and no cost for the Kubernetes control plane. So when it comes to scalability, you can easily scale applications horizontally or vertically based on demand, and also it supports for auto scaling for both applications and nodes. So some of the key components I would say for AKS are the cluster, which is again a group of virtual machines managed by Kubernetes. And when it comes to node, which is a single virtual machine in the cluster where the containers run. And pod, which is the smallest deployable unit in Kubernetes, which contains one or more containers. And namespaces is the logical separation within the cluster for different environments or teams. And then we do have ingress, which manages external access to services running in the cluster. And then finally we have the Helm charts, which is a pre-configured Kubernetes application template. So you have to understand, you have to learn all these, and we'll see the benefits. So it's very ease of use, and it helps us for better scalability, and it's very resilient and cost efficient. And it supports Azure Active Directory, which is Microsoft Entra. which enhances the security in terms of integration, the RBAC and network policy. Actually, there are lots and lots of things that I have to learn, but again, I would say we are going to discuss all these in the upcoming videos. But again, AKS is the one thing that you have to learn. And again, when it comes to the cloud part, you have to learn Azure. Azure end to end has to be learned. That's a cloud platform. So let's see that real quick. And now let's move on to the next stage, which is for the deployment and for the releases. So for deployment, you have to learn Terraform. So Terraform is actually an infrastructure as a code, which we normally call it as IAC tool, that allows you to define for provision and for managing cloud infrastructure using a declarative configuration language. It's actually cloud agnostic, and it supports Azure, AWS, GCP and other providers. So I personally would advise you to learn Terraform, and we're going to see about lots and lots of videos on Terraform in the upcoming days. So why learn Terraform? So it's actually an infrastructure automation tool where it simplifies the process of deploying and managing infrastructure. And when it comes to version control, so infrastructure changes can be tracked and rolled back, and that's very important when it comes to the code. And it also reduces manual errors and ensures consistent environments. So when it comes to reusability, you have to use modules to share and reuse infrastructure organization. So you can actually install the Terraform CLI, and we can write configuration files, and we can again, the process goes like initializing the Terraform, planning and applying changes, and then finally integrating with the Azure DevOps pipelines or along with the GitHub. And we can store the state file. So all these are possible in terms of Terraform. You can make magic with the Terraform. And just to give you a quick understanding of the benefits, so it actually helps you to automate the provisioning. So if you want to create a machine, or if you want to make a deployment, you can just do it in a fraction of seconds, because you already have all the code and you can just automate them. And it can actually enable multi-cloud and hybrid cloud infrastructure management. And Terraform actually facilitates collaborations through remote state file and version control. So you don't need to worry about the state file. You can actually store the state file in some remote location, and then you can access it using Terraform. So all these are possible through Terraform, which is not possible through any other tools like infrastructure as a code tool. Again, there are options, but still, I would say on the other hand, like Terraform is from HashiCorp. That's a very big organization, and actually they release regular updates. So it's actually a very good tool in terms of infrastructure as a coding and for deployment. And moving on to the next one, which is the Helm. So for the process of releasing, so Helm is actually a packaging manager for Kubernetes, and it simplifies the deployment and management for Kubernetes application by using pre-configured application definition called Helm charts. So you can actually use Helm charts for doing the Kubernetes deployment. So why we should learn Helm as part of the DevOps journey? So it actually simplifies the deployment, ranging from complex applications to any simple application for Kubernetes, and actually it shares and reuse the Helm charts across projects. So you can actually share, and actually we can reuse the Helm charts as well. So we can customize the deployments using value files, and also it works seamlessly with Azure DevOps for automated deployments. So that's the reason again and again I'm talking about the tools whichever sits and which works along with the Helm. And the process to use Helm is very easy. You can just install it, and you can create the Helm charts, and you can do the packaging and deployment, and you can integrate Helm with Azure DevOps pipelines. And just to end with the benefits, actually it simplifies. Helm simplifies the Kubernetes application management. It also reduces the complexity of Kubernetes configurations, and it integrates easily with AKS, the Azure Kubernetes Service, and also it supports versioned and rollback ready deployments. And overall, I would say you have to learn Azure as a cloud if you want to become an Azure DevOps engineer. So you have to learn about what is a virtual machine, you have to learn what is a virtual machine scale set, you have to learn about what is a Microsoft Entra, what is a Microsoft Entra ID. There are like lots and lots of stuff. So, again, we are going to discuss all these in the upcoming videos. We are going to see a lot about Azure Cloud and everything. So I believe this video will be very useful to you. So until I meet you in our next video, it's bye bye from Sachin Mugam and your favorite DevOps studios. Take care and bye bye.